Today's lesson is about application of exponential functions. Let's check some formula we got to use for application of exponential functions. For the following formula, A stands for the new amount, B stands for beginning amount, R stands for the rate. You can change percent into decimal when you're working on the problem. T stands for the time. For compound interest formula is this one. N stands for different number. When we do compound daily, N stands for 365. When we do compound monthly, N equals 12. Quarterly means N equals 4. Annually means N equals 1. When we have continuously compound interest, the formula will be this one. For exponential growth, here's the formula. Exponential decay, this will be the formula. Double every hour or every day or every second, this will be the formula. When we have half limited every hour, day, second, minute, this will be the formula. Half-life formula is special, like this one. You have to use this formula to find the K first. Then you plug back in to find the A. Let's go to examples. There are 50 rabbits on a farm. They are increasing at the rate of 12% every month. How many months will it be until there are 1,000 rabbits? We know here's the formula for exponential growth. We know A equals 1,000 and P equals 50 and R equals 0.12. Normally we change percent into decimal. And we're looking for T. So we set up 1,000 equals 50. 1 plus 0.12 to the t's power. Then we got 1,000 equals 50 times 1.12 t's power. Then we know this is an exponential equation. Isolate the exponential form on one side. Therefore, we divide by 50 both sides. So we got, this is a 20 equals 1.12 t. Then we got log base 1.12 both sides. So on the right side we got the t. On the left side we put into calculator, we will get 26.43. T stands for the month, so we could see 27 months. This question is a round-up question. Let's say that we had 750 coyotes that were decreasing at a rate of 3% per year. How many years would it be until we had only 100 coyotes left? This time we got to use the exponential decay formula. We are given A equals 100, P equals 750, R equals 0.03. We're looking for T. So plug in, we got 100 equals 750 times 1 minus 0.03 T's power. We organize this one, we got 0.97 T. 750 times equals 100. This is an exponential equation. We need to isolate 0.97 T. Therefore, we divide 750 both sides. So we got 100 over 750. You don't have to simplify because anyway we need to put into a calculator 0.97 T. Then we got to do the log base 0.97 both sides. So we got T equals 66.15 years. For number 3, determine the principal P that must be invested at 7%, compounded monthly, so that 200,000 will be available for retirement in 15 years. This is a compound monthly, that means N equals 12 for this formula. So we write down the formula first. A equals principal 1 plus R over 12, 12 times T. We are given A equals $200,000. R equals 0.07. T equals 15. We are looking for this principal. Now we plug into this formula. We got 200,000 equals P, then 1 plus 0.07 over 12. 12 times 15. When you look at this equation, you could see this is a linear function. Therefore, we just divide by this coefficient 1 plus 0.07 over 12. 12 times 15 both sides. Then we got this P. We put into calculator, we will get, so we got the P equals 70,201.38. Now let's go to number 4. If you invest $1,200 at an interest rate of 1.3% compounded continuously, how much will you have in 5 years? How long will it take for your investment to double? First of all, the formula you got to use is this formula. A equals P times e to the RT's power. For A, we already know P equals 1200. Rate equals 0.013. T equals 5. I'm looking for A. So we plug in this formula, you got 1200 times E, 0.013 times 5. we put into calculator, you will get 1,280.59 in 5 years. Now let's go to B. We are given P equals 1,200 and A equals 2,400 C double. And R equals 0.013. We are looking for T. So we plug in the formula, we got 2,400 equals 1,200 times E, 0.013 T. This is an exponential equation. So isolate the exponential form first. Therefore, we divide by 1,200 both sides. You will get the 2 equals E, 0.013 T. Then take a natural log both sides. You will get 0.013 T equals natural log of 2. Then we divide by 0.013 both sides. You will get the T equals. So you have to wait 53.32 years. Or you could say 54 years to make your principal doubled. For number 5, determine the interest rate. If you want to invest $10,000 compounded annually, and $50,000 will be available in 15 years. We got to use this formula. Since it's compounded annually, that's n equals 1. Therefore, I will get the A equals P0, that means original principal, and 1 plus R to the T's power. We already know A equals 50,000 and P equals 10,000. T equals 15 years. Then we are looking for this R equals. So we plug in to the formula, we got 50,000 equals 10,000 times 1 plus R and a 15th power. This is a power equation now. Therefore, we isolate the power on one side by dividing $10,000. You will get 5 equals 1 plus R to the 15th power. Now we got to do 15th root both sides. You will get the 1 plus R equals 15th root of 5. Then R equals just minus 1. Both sides, you will get this minus 1. Then we plug into calculator, you will get R equals 0.113. That means R equals 11.3%.